Hello guys. So today we will start with the problem. Fun. So it is day 3. Now code forces around 962. So the problem states. The problem states we are given two integers n and x. We have to find the number of triplets a, b, and c positive integers such that these conditions are met. A plus ab, ac, and bc should be lesser than equal to n, and a plus b plus c should be lesser than equal to x. So note that the order matters. So it could be a permutation. So our treatise is different. A, B, and C must be strictly greater than 0. Okay. So D, A, B, and C should always be greater than equal to 1, right? So the minimum value of any of this is 1. So this is one thing. Okay, I will move to the cleaner space. So what was the minimum value? A, B, and C. So these are always greater than equal to 1. Okay. A, B, B, C, and C, A should always be lesser than equal to n. A plus B plus C should always be lesser than equal to x. Okay. So okay. So we can see what would be the maximum value A can have. Okay. So we can see, like, if we put the minimum value to this, we cannot put 0 here, right? So we will put 1. Okay. So we can find the maximum value A can have, right? So what will be the condition? Lesser than x we have, or the minimum values we have, and A we have. A we don't have. Okay. So A should be lesser than equal to x minus 2. Okay. So this is our first condition for this. So for this, what we can say is a into 1 plus we have b. Okay. B is 1, c is 1, then we have c is 1, a we don't have. A lesser than equal to n. So I will write here. So a plus 1 plus we have a should be lesser than equal to n. So a will be lesser 2a will be lesser than equal to n minus 1, and a is lesser than equal to n minus 1 by 2. This is our second condition. So we have to follow the both of this condition. Okay. So a will always be lesser than both of this value. So we can take the minimum of this and it will be lesser than that minimum value. A always be lesser than any of this, whatever the minimum. Okay, let's jump to the code and, like, we will move forward after that. We'll write n comma x machine and x. We'll maintain a count for the answer. For int a equal to minimum, it will start with 1. So a should be lesser than equal to, as we told, minimum of x minus 2 comma, it was x minus 2 no? Yeah, and n minus 1 by 2. Okay. So I'll put a bracket here. Okay. And a plus plus. So is it one extra bracket? Okay. Yeah. So after we run, so this like, from this we will get the first value in, like, the permutation. So a we got, we have to find b and c. Okay. Let's check on that. Okay. So b will also can be minimum 1. B should be lesser than equal to, what could be the condition here? Okay. And B will increase. So we have to find this. Uh, at this point of time, we have the A, we have N and X, and let's see, like, how we will find. Okay. So a plus b plus c lesser than equal to x. So if we have a and we don't have b, the minimum value c can have is 1. So b is lesser than equal to x minus a minus 1, right? So b will always be lesser than equal to this. And what about the other condition? A, B, P, C, C, A lesser than equal to n. So we'll put this. So we have to take B common here. B, A plus C plus C and A. So C we are putting as 1, right? So C, the minimum value C can have is 1. Okay, that's why. So it's A only and n. So if we take this, so n minus it will go there and become minus, and below it will c is 1, so a plus 1. So this is our another condition, and one of condition is this. So b will always be lesser than any of this, any of this, like whatever the minimum value. Okay, suppose this is 10, this is 9, so b will always be lesser than minimum of 10 comma 9. Okay, so it will be b will always be lesser than equal to 9. That's why like we are taking the minimum of this value. Okay, so let's jump to the code again. So what was that? Yeah, so we will take the minimum of x minus what, a minus 1, c is 1, and another was n minus a divided by what was that, divided by a plus 1, right? This was our condition. I proved the bracket here. Okay, now we run for loop. Okay, let's see one thing. At this point of time we have a, we have b, we have n, and we have x. So I think we don't need to run a for loop for c. Like a plus b plus c always be lesser than equal to x. So if we have both of these values, all three values, so we easily get x minus a plus 9, a minus c. C. I'll remove this. Okay, so c will always be lesser than equal to x minus a. So what would be the maximum value c can have? This one. Okay, and what for another? A b b c c a lesser than equal to n. So I'll write it here. So n minus a into b divided by, if we take c common here, so it will be b plus a. So we'll put it here, a plus b. Okay, so c will always be lesser than equal to this condition. Okay, so do we need to run a for loop from 1 to till this of minimum value, and like every time we will just increase the count only now, right? Like to increase the number of permutation, so we can just directly return an answer minimum of any of this value. Suppose this is 9 and this is 10, and c can have 1 2 3 4 maximum till n. So our count will be equal to n only now. Like count will be increased by maximum 9, right? So we can just directly do that. Okay, so we will write this condition, c x minus a minus c. So count plus equal to x minus a minus c. Okay, so we'll take the minimum of this, minimum of this. C we don't have, it is B. I think I by my mistakenly wrote it C. So it is B, yeah. So like this will go there and C will be lesser than equal to this. Okay, and the minimum of this now. So what for n value? So n minus a into b divided by a plus b, right? Let's put the code here. And we will print this cout cp count. Okay, uh, let's run this. For this output you can see. Okay, okay, thank you.